Hi everyone, today we're going to go through an introduction of physics. So let me go ahead and get started by starting to talk about what physics is. And to understand physics, we need to understand science. So remember that science is a set of theories and laws that are general truths of nature and the body of knowledge they encompass. So we have many different sciences. In particular, we are going to be focusing on physics. Okay. Now, physics describes the phenomena in nature and the interactions between energy, matter, space, and time. Okay. And it explains the fundamental mechanisms underlying each of these phenomena. And we use physics to understand the function of everything. Okay. So this is a base to understanding many different sciences. And what I want to talk about today, and it's going to be a little bit rigorous, but we're going to go through units that we use, a little bit of an overview of trigonometry, and then vectors. Now, I don't know if you guys have heard of vectors, but I'm going to go through it step by step to kind of get you guys on that path of understanding vectors. So, units describe a physical quantity, okay? And we use the SI system, and I will talk about that in the next slide. And the metric system here, we have length, mass, and time, okay? And I also have a chart here that shows you the different scientific notations and prefixes as well as their meanings. Okay, so if I say that I want to go 10 centimeters, okay, so if I want to go 10 centimeters, pen's not working yet, okay, we all can kind of visualize that, right? But if I want to say, well, okay, you're saying 10 centimeters, but what does that really mean? I can go to this chart and I can write that in a different, either scientific notation or write it out in a different way. So how many meters is it really? Okay, because I'm saying it's centimeters. Okay, so I'd be looking here. Centi, which has the symbol C, which is why I have a C here. And so that means that I have 0.01 meters, okay? Or in scientific notation, I can say it's 10 to the negative 2 meters, okay? So understanding scientific notation and their meanings of all of these prefixes is going to help you throughout this course and then the following courses, okay? All right, so let's go ahead and move on talking about SI units. Okay, so we have, let me move this out of the way. We have that there are these base quantities or units, and these are defined units. So these were defined by humans. Okay, then we have derived quantities and units, and these are algebraic combinations of the base units or quantities. Okay, so we have defined what a meter is. A meter is this amount of length. Okay, we have defined that the kilogram is the base unit, and we say it's this amount of mass, and so forth. Same with seconds. Amps, which you'll probably see next semester, Kelvin, which is temperature, mole, and luminous intensity, okay? And so we are going to be focusing on the first few quite a bit, okay, in this course. But these are the base units in the SI units, okay? So with that, we want to look at the derived units. So probably in math, you guys have had to figure out an area of a square, okay, or a rectangle, and a volume of a cube, okay? So let me show you what I mean by derived units. Okay, so we said that length has the units of meters, right? Okay, well, so if I'm trying to find an area, and remember that area is length times width, okay? And say I have that it is, I don't know, 1 meter by 2 meters, okay? My area, what I would do is take my length, 2 meters, multiply it by my width, 1 meter, and I get 2 times 1 is 2, and then meters times meters is going to be meters squared. Okay, so my area here is 2 meters squared. Okay, so my derived units here is this meters squared. Okay, so now we know that area has the units of meters squared. Okay, now we can do something similar with our volume. Remember, volume is length times width times height. So I have some sort of length here, which this looks like a perfect cube, so I can say it's 1 meter by 1 meter by 1 meter. Okay, so my length times width times height. And of course, 1 times 1 times 1 is 1. And then meter times meter times meter is meters cubed. So again, my derived units now is meters cubed. Okay. So these are a couple of derived units. We can go even to velocity. So remember that velocity is a distance over a time. Distance has the units of length. Okay, so that's going to be in meters. Time, we can have it in different units, but remember in SI units, we use seconds. Okay, so again, based on our base units, okay, we derive another set of units. So our units now for velocity is meters per second. Okay, and we could do the same thing for acceleration. Acceleration is the change, the rate of change of something. Okay, so it's usually the change in velocity. So we would say velocity over time. Okay, so that's going to be meters per second divided by seconds. And so that is going to give us meters per second squared. Okay, so these again are all derived units, and we'll see that again throughout the course. Okay. All right, so going on with our unit discussion, we need to know how to use our units and convert them between each other. Okay, and this is a process called dimensional analysis. Hopefully you guys have learned a bit of this before, maybe in high school or in another math class. Okay, but basically we want to be able to move from one type of unit to another. Okay, so think about it as, let's see, if you want to know how long, I don't know, you need to cook something, okay, but it's only giving it to you, the recipe is only giving it to you in hours. It's saying 1/2 hour. Okay, well, we know, because we've looked at time for so long, that would be 30 minutes, right? Okay, but you're doing dimensional analysis in your head while you do that. You're just not thinking too much about it, I guess. Okay, so if I said 1/2 hour, let's say 0.5 hours that I need to cook this, and I want to know how many minutes, okay, what I'll do is I'll use one of these conversions, one of these conversions to do that. Okay, so these are all lengths, and then I've got my time down here. Okay, so what I'm going to do is I'm going to take the conversion between hours and minutes, so that's this first one here, and use that to see how how long in minutes I need to cook this food. Okay, so I'll take that, I'll say, okay, so there's 60 minutes in 1 hour. Okay, and notice when I'm doing this, and sorry my handwriting is a little sloppy, it's kind of hard to use these technologies, but as I do this, notice where I placed everything. Okay, so this was my initial, okay, my given value, and this was in hours. Okay, I want to calculate this in minutes, so I'm trying to translate that into minutes. So I need that value on top, minutes, okay, and hours to be on the bottom. And the reason why is because I want my hours to cancel out. Okay, so now I have my units of hours canceled, and I'm just left with my units of minutes. Okay, so now I have 0.5 times 60 divided by 1 minutes. Okay, maybe rewriting it like this might help. Okay, then you get half of 60 is 30 minutes. Okay, so this is what I mean by dimensional analysis, and it can be much more involved than something so simple as this, but hopefully through doing some practices, I will also have a video up that hopefully will kind of help you with that dimensional analysis, unit conversions. Okay, so we can do this with lots of different things, not just time. We can do that with length as well. Those two are very common for us to do. Okay, you can also use this, I should mention, when you are, say you're given a mass in grams. Okay, so say you have 2 grams of something and you need it to be converted to kilograms. Okay, you can use the chart that I showed you earlier. Let me go back. Here, the scientific notation chart to convert between these things. Okay, so if I have my grams and I want to go to kilograms, kilo tells you that it's 10 to the third. Okay, so to get from grams to kilograms, there are 10 to the third grams per 1 kilogram. Okay, that's what this means. Okay, same thing if I'm going from kilometers to meters or meters to kilometers. Okay, if I'm saying there's going to be 10 to the third kilometers, 10 to the third meters in 1 kilometer. Whoops, that should be an M. Okay, so these are equal. Okay, so these are other conversions. Okay, so if I go back and I say, okay, I want this in kilograms, what I will need to do is say, okay, I'm starting with 2 kilograms and I want to end with 2 grams. I want to end with kilograms. Okay, so in 1 kilogram, there are 10 to the third grams, or remember that 10 to the third equals 1,000. So if you're entering it into your calculator, you think that one of these ways is easier, no worries, as long as you get to the right answer, okay? So then you would plug that into your calculator and get your value in kilograms. So what I will do is I'll put it in scientific notation, okay? And that'll be 2 times 10 to the negative 3 kilograms, okay? All right, so I'm going to go ahead and move on to significant figures, and I will continue this in the next video. I'm going to try to keep these pretty short videos so that way you can take breaks in between lectures, okay? All right, we'll see you in the next video.